Welcome to the project demonstration of self-charging electrical bicycle along with manual power also. So in this project we have the three features. One is pedaling manually mechanical energy to mechanical energy, and the next electrical energy to mechanical energy with help of this PMDC motor, which is of 250 watts 24 volts DC motor, which is driving getting power supply from this or 24 volts battery. So in this battery pack we are using two 12 volts 7.5 ampere per hour batteries, so which is rechargeable batteries. Charger there. So and the next there is a one controller which is used to control the speed of this PMDC motor 250 watts based on the input from this throttle. So this is a throttle, we are going to control that. And also there is a one more key on off switch. So this is on off switch, off state and on state. So now it is off. So it's a throttle can increase the speed, and this is a charger to make a full charge of this battery. So here we need to connect this battery in this manner to the charger. So it will accept in this manner only. Let's lock this. So and give the power supply to this charger 230 volts. So there's a light indication over here. So when you on the charger, so initially it will show the red light as the battery is charging. So when it's turned to the green, then automatically the battery stops charged, and next you can disconnect this from the battery. Right. So now as we discussed, we are using 24 volts 7.5 ampere per hour battery and a 250 watts PMDC motor. So the base motor provides us the 1800 rpm, and after this gearbox we are getting 600 rotations per minute. So that was given input to the our main wheel, back wheel, through this sprocket gears. So one is a free wheel, this is a sprocket gear, and next is a free wheel. So there are two free wheels attached. So one free wheel for the pedaling purpose, another free wheel for our PMDC motor rotations. So next, as we discussed, the self-charging electrical bicycle. So this is the dynamo, can generate 20 watts of power with 24 volts. So generally it can generate up to 28 volts, so which is sufficient to charge our 24 volts battery, because we need to provide the maximum power than the battery voltage, then only the battery will get fully charged. So from there to the charging section, this is the charging section, and from this green wires we are providing the power supply to our battery. So this charger consists of the two diodes along with 4 diodes. These 4 diodes will act as a bridge rectifier. So generally the bridge rectifier purpose is convert to AC to DC, but in our project we are making use of this polarity correctors. Why? Because when we are rotating in the backward direction, then this will the DC generator provide us the negative polarity, and when it's forward direction, positive polarity. So in order to convert that positive polarity, negative polarity to the exact plus to plus, minus to minus, so then these 4 diodes will act as a rectifiers. So nothing but polarity correctors. For example, we are rotating this cycle backward direction, then at this black will get the positive and the red negative. When it is forward direction, again, so black is going to be the negative only, red is the positive. So then the polarity is changing while the change of directions. So in order to rectify that, we are making use of this rectifier, and after that there is a filter to provide us the pure smoothing one, and then given to the battery directly. So there is a two way of charging. One is a battery from the dynamo, and another is from 230 volts AC input. So let us see the demonstration. So now let us see, let me show you the demo of dynamo. So the key on, and the next, so we can see the indication, because it's showing the status of the power is generating from our dynamo and given to the battery. So let us see demonstration directly. Mechanical, stop, and electrical.